Good morning, everyone. Myself Devika, working as assistant professor in the Department of Electrical and Electronics Engineering at Sri Muthukumaran Institute of Technology. Today we have discussed the subject on W25C01 Basic Electrical and Electronics Engineering for 2025 regulations. In this presentation, we have discussed the topic Silicon Control Rectifier (SCR). So commonly known as SCR, which is on important power semiconductor devices used for controlling electrical power. Then contents. This it covers the introduction, construction, working principle, characteristics, importance, applications, disadvantages, and conclusions of SCRs. Introduction. So that SCR is that means a silicon control rectifier is a three-terminal semiconductor switching devices. So it is widely used in power electronics for controlling and regulating electrical power. So it acts as a controllable switch and it is capable of handling high voltage and high current. Now, what is SCR? So, SCR stands for Silicon Control Rectifier. It is a semiconductor device. It consists of three terminals: anode, cathode, and gate, and four layers: PN, PN, 2P layer, and 2N layers. Then, gate terminal controls the switching action of the SCR, and it allowing current flow from anode to cathode. SCR constructions. So SCR is made up of four semiconductor layers, PN, 2P layer, 2N layers, and it has three junctions J1, J2, J3, three terminals, anode, cathode, gate. So creating three terminals J1, J2, J3, the anode is connected to the outer P layer and the cathode is connected to the outer N layer and the gate to the is connected to the inner P layer. So the outer P layer where the two electrodes are placed will be a heavily doped and the middle P and N layers will be lightly doped. So the gate terminal will be connected to the P layer in the middle. Then working of SCR. So SCR operates with the anode is positive with respect to the cathode. Depending on the applied voltage and gate signal, it operates in three modes: forward blocking mode, forward conduction mode, reverse blocking mode. Then forward blocking mode. In this mode, the anode is positive and the gate is open. So junctions J1 and J3 are forward bias, while J2 is reverse bias. Only a small leakage current flows and the SCR remains in the off state. Then forward conduction mode. In this state, the SCR transition from its blocking phase to the conducting current. So this shift can be triggered in two ways. So this mode, cathode is positive and anode is negative. Uh, Gate pulse is applied or anode voltage exceeds the breakover voltage. So the SCR turns on and its current flows freely through the device and it behaves like a closed switch. Then reverse blocking mode. In this mode, the cathode is positive, is connected to the positive voltage, while the anode is connected to the negative voltage. So the junctions J1 and J3 become reverse bias and it preventing current flow. So only a very small leakage current is exists. Then importance of SCR. So SCRs can handle high voltages, high power and high currents and high power levels with ease. It triggers mechanism is straightforward, making activation simple and reliable. Then turning the SCR on requires minimal effort and its protection is easily achieved through the uses of fuses and it excels at regulating alternating current power. Control over its operation is uncomplicated. The device is cost effective, offering great value, with switching speeds reaching up to 1 billion operations per second. So SCRs deliver exceptional performance. Then application of SCRs. SCRs are used in controlled rectifiers, inverter circuits, battery chargers, voltage regulators, and motor speed control systems, power control circuits, and such protection devices. Then disadvantage of SCR. It is a unidirectional device and it can conduct only in one direction. So it requires positive gate current for triggering and it is not suitable for high frequency applications. Conclusions. So SCR is an efficient power switching device that operates either in on state or off state. So it can be triggered using a gate pulse and it is widely used in power control applications due to its reliability and power handling capability. References. These references include standard textbooks on electrical machines and power electronics used for preparing this presentation. Thank you.